So in order to determine how to implement computer logic into Never Losing in Tic-Tac-Toe, we researched online, and what we found from our research is that the first moves were obviously the most important. Within these first amount of moves, the game could either be won or lost. So what we did is that we found a great picture showing the different types of moves that we would have to take in order to prevent ourselves from losing the game. As we can see here, this is the picture that we used, and the moves shown in gray right here are the moves where if we put down a marker there, then the human would have a chance at winning. So anywhere in these places where you do not want to put a move down, but anywhere where there's white spots, those are the moves where you should go if you don't want to lose, right here. We found that obviously from that chart, the human puts a marker in the middle, we have to put a marker in the corner piece, or if the human puts the marker on the corner, then the only move that we can take is the middle piece, as you can see from here.
So when we did our computer logic, we wanted the computer to take the middle piece if the computer went first. This was the most commanding move, and after the first couple of moves from both human and computer, the logic was to either block the human from winning or to place a marker in a winning move. In this way, the computer never lost, and the game would always play out to a draw.
Other methods that we've researched always had our move being placed around the person's marker that they would do. And this method focused more on draws and would have created longer games and had more code to write. That is why we chose our method, which was simpler and had less code.
So now that we had the computer logic done, we now had to implement the robot functions into our computer and make sure that it would run the way we wanted it to run. So the first thing we had to do is that we had to scan in the current board state into our computer, so then the computer can use that logic and decide its next move from there. And as we found at first, when we had to scan in all the pieces, we found that if you just scanned in the middle piece and then you just did one loop and scanned in all of the outer pieces, that some of the pieces wouldn't scan in correctly because they were blue pegs, and if you happen to use the color blue in your set of logic, it would accidentally scan that blue peg as a blue marker. So what we did is that instead we scanned in the middle piece first, then when we were done with that, we scanned the edges in a circle. Then once we were done with that, we scanned the corners. And finally, once we had this scanned in board, we inputted it directly into our logic.
Alright, once the board was imported into our computer logic, the logic would export an X and Y value for the move. This meant once we got the X and Y value, we could import that into our move function, and then the robot would be able to place a marker correctly on the board.
Both the computer versus human and the computer versus computer videos are located in the comments section.
This concludes our presentation of the robot, and these are our citations.